Turbine bearing maintenance. 2013. 12. 4. Park, Jongjun. Principal Technical Expert. Power Operation Division. Contents. 1. Journal bearings in general 1. 2. Elliptical journal bearing. 16. 3. Double tilting pad bearing. 31. 4. Thrust bearing. 44. Turbine bearing maintenance. Turbine generator main journal bearings are designated as number 1, 2, 3, 4, etc. starting with the turbine end bearing at the front of the machine. All bearings are oil-cooled, with a pressurized oil supply to maintain suitable operating temperatures. 1. Journal bearings in general. 1.1 Introduction. 1. Turbine bearing maintenance. Action of cylindrical sleeve bearings. Support the rotor. Utility turbines use journal bearings instead of ball or roller bearings. Journal bearings have a smooth surface of a soft material called babbitt. 2. The bearing ring at the collector end of the generator is insulated from the end shield to avoid the possibility of stray shaft currents circulating through the bearings. Generator insulated bearing ring. Turbine bearing maintenance. 3. Shimmed pads are provided on the bearing or ring OD to adjust bearing alignment. For the fixed bore bearings, an anti-rotation pin is located in the ring and extends into the bearing shell to prevent bearing rotation. Tightening bearing strap bolts. Turbine bearing maintenance. 4. 1.2 Maintenance recommendations. In the event that any of the babbitt surface is scored or smeared, upset portions of metal may be carefully scraped off. Excessive scraping of the bore, however, should be avoided. Any indications of cracks in the babbitt should be investigated with a liquid penetrant test. If cracks actually exist, the bearing should be rebabbited at the earliest opportunity. Turbine bearing maintenance. 5. 1.2 Maintenance recommendations. The curvature of the pads of tilting pad bearings should be checked by bluing to a mandrel of diameter equal to shaft diameter plus diametral clearance. Turbine bearing maintenance. 6. Any sharp ridges or upset metal may be carefully smoothed with a fine stone or by lapping with very fine emery cloth. No attempt should be made, however, to completely remove such imperfections, because hand operations may change the contour of the journal sufficiently to adversely affect the balance of the rotor. Turbine bearing maintenance. 7. Each journal should be measured in 2 planes, 90 degrees apart, at 1 in 25.4 mm intervals along the active surface. If diameter measurements vary by more than 0.004 in 0.1 mm from each other, or if there is more than one major score mark, i.e., one which is greater than 1/64 in 0.397 mm in depth per in 25.4 mm, it should be restored by complete remachining. Turbine bearing maintenance. 8. Turbine bearing maintenance. Characteristic temperature spike. 9. The fit between alignment pads and the standard should have a minimum of 80% contact, 100% around feed and drain holes. Be sure the shims placed under pads containing feed and drain holes are provided with openings to pass oil. After making contact checks and completing assembly of the bearing, a feeler check should be made between alignment pads and the supporting fit to be sure the bearing is not riding on a burr. Turbine bearing maintenance. 10. Turbine bearing maintenance. For this check, a 0.0015 in 0.038 mm feeler should not fit between the parts. 11. On bearings with a ball seat, it is necessary to measure twist and tilt and make comparisons to allowable limits. Tilt limits for hood bearings are established such that with proper alignment, the bearing outboard end is set slightly low. When vacuum is drawn, the bottom of the bearing becomes more nearly parallel to the journal. The double tilt pad type bearing, no ball seat, is the only journal bearing design with truly self-aligning capability, and it does not require twist and tilt measurements. Turbine bearing maintenance. 12. Tilt. Turbine bearing maintenance. 13. Twist. Turbine bearing maintenance. 14. 1.3 Repairing bearings. As the maximum allowable vertical bore clearance is approached, consideration should be given to repairing the bearings. When the babbitt to steel bond is sound, welding via the TIG welding process, followed by remachining, may be used to restore the bearing bore. Whenever a bearing or bearing ring is repaired, it is essential that these parts be blue checked and fitted together so that the area of contact is at least 80 to 85%. Turbine bearing maintenance. 15. The 2 types of elliptical bearings used are the standard elliptical and the short elliptical. The bore of these bearings is an ellipse with the major axis horizontal and the minor axis vertical. After babbiting, both halves are machined as a unit and must be kept together as a matched set. A dowel projecting radially from the lower half bearing engages a slot in the bearing bracket to prevent the bearing from rotating. 2. Elliptical journal bearing. 2.1 Design features. Turbine bearing maintenance 16. Elliptical journal bearing. Turbine bearing maintenance 17. Turbine bearing maintenance 18. Turbine bearing maintenance. Operating characteristics of the elliptical bearing. 19. Inspection. It is usually not necessary to inspect a turbine journal bearing between regular overhaul or inspection periods unless there is some indication that such an inspection is necessary. At the regular overhaul period, each journal bearing should be inspected for condition, clearance and alignment. Turbine bearing maintenance 20. Measuring bearing clearance. Elliptical journal bearing. Clearance measurements should be taken with the bearings and turbine rotor at ambient temperature. Turbine bearing maintenance 21. Aligning a bearing. 2.2 Maintenance. When a journal bearing is installed, it is essential that the bore be aligned parallel and perpendicular with the axis of the journal. It cannot be assumed that because the bearing has a ball seat it will align itself automatically with the shaft. When a bearing is misaligned, the unit loading is increased and the maximum oil film pressure may increase considerably, resulting in higher oil film temperatures. Turbine bearing maintenance 22. Rotor journal contact check. 2.2 Maintenance. Turbine bearing maintenance. L1, L2 must not exceed 1. 3. 23. Bearing ring fitting to pedestal. 2.2 Maintenance. Turbine bearing maintenance 24. Bearing ring contact to pedestal check. 2.2 Maintenance. Turbine bearing maintenance 25. Bearing ring contact to pedestal check. 2.2 Maintenance. Turbine bearing maintenance 26. Bearing ring contact to pedestal check. 2.2 Maintenance. Turbine bearing maintenance 27. Pinch check. 2.2 Maintenance. Turbine bearing maintenance 28. Ball seat torque check. 2.2 Maintenance. Turbine bearing maintenance 29. PR gauge. Inner ring. Ball seat torque check. 2.2 Maintenance. Turbine bearing maintenance 30. 3.1 Introduction. Certain bearings on turbines see relatively light rotor weights and can be lightly loaded under some conditions. To prevent shaft instability in these cases, double tilt pad (DTP) bearings are used. These bearings are normally used to support the high pressure HP and reheat RH elements of such turbines. Recently, new units have been shipped with a DTP bearing at the first hood position also. 3. Double tilting pad bearing. Turbine bearing maintenance 31. 3.2 General design. The back of each pad has a smaller radius of curvature than the casing bore, so as to be free to pivot in the direction of shaft rotation. This allows each pad to assume an optimum oil film wedge. A large radius is also machined on the back of each pad in the axial direction to allow the pads to align themselves to the journal. Hook fits on the casing retain the pads during handling and each pad is prevented from rotating by means of a loose-fitting locking pin. Turbine bearing maintenance 32. 3.2 General design. Turbine bearing maintenance. Annulus. Groove. Locking pin. Adjust. Plate. Feed hole. Alignment. Pad. Seal tooth. Cover. Half. Ring. Pad. 33. 3.2 General design. Turbine bearing maintenance 34. 3.3 Maintenance recommendations. Anti-rotation pin. Check the condition of the pin visually and with liquid dye penetrant. Worn, bent, or cracked anti-rotation pins must be replaced. These are specially hardened pins and only factory replacements should be used. Turbine bearing maintenance 35. Pivot surface. Inspect the back of the tilt pads for excessive wear or fretting. Turbine bearing maintenance 36. Pivot surface. Measure the location of the pivot point from the leading and trailing edges of the pad. Generally, the pivot point will be located 0.50, 0.70 times the circumferential length of the pad from the leading edge, and 0.50 times the axial width of the pad from either side. Turbine bearing maintenance 37. Inspect the anti-rotation pin holes in the back of the pads. These should be round. Turbine bearing maintenance 38. 41. Any of the hardened bushings located in the upper half pads should be replaced if worn to a depth exceeding 0.010 in 0.25 mm. Any holes in the lower half pads that have worn more than 0.125 in. 3.18 mm deep should be bushed and re-drilled. Turbine bearing maintenance 39. 42. Pads having loose, cracked, or heavily pounded babbitt should be replaced. Pads should be replaced if anyone has more than 35% of the babbitt steel interface area unbonded at the top of the dovetail. When checked ultrasonically, pads that pass ultrasonic testing but possess surface damage such as scoring, smeared babbitt, or heavy wear should either be replaced by new pads or restored, removing the damage by welding babbitt using the TIG process, and machining to original design. Babbitt surface. Turbine bearing maintenance 40. Babbitt surface. Turbine bearing maintenance. Exfoliation rate must be below 20% of total babbitt area. 41. Tilting pads with only light wear, not requiring babbitt welding or replacement for other reasons, must be individually blue contact, checked against a mandrel of proper curvature. The mandrel should be straight and round within 0.001 in. 0.25 mm, with at least a 63 RMS surface finish. Each pad should have a minimum of 80% contact to the mandrel. Under no circumstances should the tilt pads be blued against the shaft. It is permissible to wrap a shim of suitable thickness around the shaft to arrive at the correct curvature for a blue check. Pad contour. Turbine bearing maintenance 42. Pad contour. Turbine bearing maintenance 43. Turbine bearing maintenance 4. Thrust bearing. Absorbs axial forces. Like the journal bearing, the thrust bearing builds up a thin film of oil between the bearing and a thrust runner on the rotor. Thus the rotor never touches the bearing surface in normal operation. 44. Turbine bearing maintenance. 4.1 tapered land type. 45. Turbine bearing maintenance. 4.2 Kingsbury type. 46. Turbine bearing maintenance. Bump test. 4.3 maintenance recommendations. 47. Turbine bearing maintenance. Stack-up check, the difference between the result of bump test and stack-up check should be below 0.05 mm. 48. Turbine bearing maintenance. Thrust wear detector. 49. Thank you.